Hello, this is Farhan Khan from the Republic 2.0, and today's topic is the projectiles from mechanics, and that is Unit 1 of Edexcel AS Physics. So, first of all, we need to talk about that what is a projectile. So, talking about a projectile, talking about the types of motion that we already know. For example, when you're defining a motion, it is the change of position with respect to the surroundings. But that change of position could be just along one dimension, like, for example, a billiard ball is just moving straight like that, right? Or that motion could also be a two-dimensional motion, right? Where a ball would be moving like that, right? With the ball covers distance along x-axis as well as along the y-axis as well. So such a motion is known as a projectile motion. So when it comes to defining the projectiles, so projectiles are, whenever you're talking about projectiles, projectiles are the objects, they are the objects which are undergoing two-dimensional motion, which are undergoing two-dimensional motion. Such a nature of motion is known as a projectile. These are the objects which are undergoing two-dimensional motion. Okay. Now, the next thing about them is, we need to learn about some examples. So the examples for the projectile motion include a ball, for example, a football that is thrown like that, right? On the other hand, for example, if you're standing on a hill and you're throwing a ball downside, that ball also gonna cover a projectile motion. Similarly, whenever a rocket is launched, right? A rocket or a missile is launched specifically. Whenever a missile is launched, it follows a projectile path, something like that. So you have got these three examples for the projectile motion. An object can move like that, or like that, or like that, right? So these are the three examples for the projectile motion. An object can cover a distance along two dimensions like that. Now the thing is that you can dissect that two-dimensional motion into two types of motion. A body would be covering, at the same time, the body would be covering the vertical motion, and at the same time, the body would be covering the horizontal motion as well, right? The body would be undergoing these two motions, straight away. Now, first of all, we need to keep that thing in the mind that whenever you're talking about the horizontal motion, there is no force which is influencing the the path, the projectile path. There is no force that would be influencing the horizontal motion. But in the vertical motion, we have got gravity. So in the horizontal motion, we've got no force that is affecting the horizontal motion, right? So whenever you're talking about the horizontal motion, whenever we are talking about the horizontal motion, we need to keep one thing in mind that the velocity along all the horizontal path would be constant. The velocity along all the horizontal path would be constant, right? But whenever you're talking about the velocity of a body, which is covering a vertical path, now the velocity going to change. It would be having a different initial velocity, and it would be having a different final velocity, right? So they both would be the different things. So now we'll talk about distances, we'll talk about the velocities one by one, and we'll talk about their formulas. So if you want to calculate the distance covered along the horizontal path, if you want to cover the distance which is covered along a horizontal path. So if you're covering a distance along the horizontal path, the formula would be just simple. You just need to times the velocity by the time taken and you'll get the horizontal distance. X is representing the distance covered along horizontal path. But secondly, whenever you're talking about the distance covered along a vertical path, you have to use a kinematic equation. And that kinematic equation would simply become y, I'm just using second equation of motion. And second equation of motion, as we both know, that is S is equals to ut plus half at square. And since we're talking about the vertical path, the acceleration would be the gravitational acceleration, and the initial velocity of an object would be 0. So S is equals to u times t plus 1 by 2 times g times t square. So the distance which I'm going to take as y, that would become y is equals to half gt square. So that is how we're going to calculate the vertical distance covered by a projectile. The formula would be half gt square. You just need to know the time, and you can simply calculate um the vertical distance. And for a horizontal distance, you need to know the velocity, horizontal component of the velocity, and you need to know the time, right? So now we'll be talking about the next thing, which are the velocities. So it's velocity. Now, one thing is for sure, whenever you're talking about velocity, first of all, in the first case, we'll be talking about the velocity along a horizontal path. And I've just told you guys that whenever you're talking about the horizontal component of velocity along horizontal path, whenever you're talking about horizontal component of velocity, you have to keep one thing in mind, that the velocity would not change. There would be zero acceleration when you're moving in a horizontal path. There will be zero acceleration because there is no force acting on a horizontal path to accelerate a substance. So what you're going to do is you're going to calculate Vx. That would just simply be u times cos theta. Just get yourself the angle at which the projectile is launched. Just get yourself the initial velocity, and you will simply get yourself the horizontal component of velocity. But similarly, whenever you're talking about, the vertical path, whenever you're talking about the velocity along the vertical path, what you can do, you have to Vy, and that's going to be u sine theta. Just get yourself the theta and the g minus gt. Gt are the, you know, i- is basically the frictional forces present in the whole of the path. So u sine theta minus gt is going to be Vy. That is the velocity along the vertical path. And if you guys need the magnitude of the total resultant velocity, that would just be the Pythagoras theorem, meaning thereby Vx square plus Vy square. So that is how we work out all of these things, right? And for the same projectile motion, we need to know that which equations of motion we're going to use to work out different things. We'll do a past paper question after that, but you need to know, for example, the first equation of motion going to be V is equals to U plus AT. That equation is very helpful. Second equation of motion is S is equals to ut plus half at square. That equation is very helpful, right? Because it gives you a relationship between the distance, initial velocity, acceleration, and time. And thirdly, you've got another thing, and that is 2as equals to v square minus u square. So you can have these three formulas, and you can work out anything that you need. You've got a relationship between the speeds, initial and the final speed. You've got the acceleration, and you've got the time. Now, similarly, we'll practice a past paper question in which such things have been asked. Now, for example, if you read question number 15, the question says that a boy is throwing a ball towards a wall, right? The height of the ball above the height of the wall above the boy is 3 meters. Angle of initiation is 49 degrees, and the initial velocity of that person is supposed to be 9.70 meters per second. And we need to show that the ball traveled the distance to the wall in about 0.8 seconds. So we need to calculate the total time, and that total time should have been 15 seconds, right? So what we're going to do, we need the horizontal component of velocity. We need the horizontal component of velocity. We need the distance. We have already got the distance, that is 5 meters. So we'll get the time initially. So to work out the horizontal component, you're just going to use u cos theta. And u cos theta comes out to be 9.70 times cos 49. Just times them up, and you'll have the final answer, which is going to be something like, for example, 6.36 meters per second, right? Now, after you've got the horizontal component of velocity, you can just simply use the formula. since the velocity would be the horizontal distance upon time. So time is going to be x upon vx, and you can just simply plug in the values. The distance was 5 meters, the speed was 6.36, and when you're going to divide them up, you would be having 0.786 seconds, which is approximately the time that we needed, 0.8 seconds. So that is how we had to do this question. Now in the B part, we need to deduce that whether or not the ball went over the wall for this attempt or not. So you guys can see that the height of the wall above the boy was 3 meters. So we'll calculate the maximum vertical height or the vertical distance covered by an object. And if that distance comes out to be greater than 3, then it could pass over the wall. But if that distance comes out to be less than 3 meters, the ball is not going to pass over the wall. So what we're going to do, we're just going to use the equation of motion. So using second equation of motion, so we're just going to use second equation of motion, and that is S is equals to ut plus half at square, right? Everybody knows that, since we are talking about these things, so we have to calculate S. So first of all, the initial component of velocity can be calculated as u sine theta times t, right? And since the ball gonna move up, so we have to use plus 1/2, but negative g times t square, right? We'll just plug in the values. You've got u. The initial component of the velocity was 9.70 and sine 49. So 9.70 times sine 49 times t, time came out to be 0.786 minus 1/2 times 9.8 times 0.78 square, right? So I've just plugged in the values. I'm going to calculate the distance, and the distance comes out to be 2.72, which is basically less than 2.72 is less than 3 meters, which was the height. 3 meter was the height of the wall above the boy. Since it is less than 2.72, which is the maximum height, so ball will not pass over the wall. So that was it. These are the type of questions that we have from the projectiles, and we need to keep talking about them. So that's it for today. If you've got any question from today's lesson, you guys can ask. Thank you very much.